In this collection of videos, we are going to talk about something called branching, and we're going to introduce a new data type, which is called the Boolean data type, which has something to do with the branching that we'll be studying. Now, before we can really get to what branching is, I'd like to take a moment to talk about flow of control. And what flow of control is the order in which the computer executes our line of code. At this point in time, we have been writing very simple programs, and the way that the computer executes the code should feel very natural to us because it's just like reading a book. That is, when we read a book, we start at the very beginning, we start at the top of a page, and we read each line once and only once, reading from left to right. Up until now, our computer programs have been running exactly the same way. They've been running sequentially, line 1, line 2, line 3, line 4. We're not rereading any particular lines of code the way that we generally don't reread sentences in a book. And we are reading our lines of code from left to right. However, in our last collection of videos when we were learning about the floating point data type, we did see some examples where we began to bend the rules a little bit on number 3. An example I can think of is when we were declaring a variable in terms of a previously defined variable. The first thing that would happen is that we would look up the value of that previously defined variable. Now, the value portion of an assignment is on the right-hand side of the equal sign, and only after we had executed the right-hand side of the equal sign would we then execute the left-hand side of the equal sign. So we started to see the bending of this rule in our last video, and it was a little bit strange. What we're going to do now is really break from this one line at a time, executing every single line in order, top to bottom, when we introduce branching. There are times in life where we don't want to do everything. Maybe we have a big, huge manual instead of a novel, and we don't need to read every bit of the manual front to back, line by line. We might look at the table of contents and jump around. In general, we're going to want to think about when we ask a question and then maybe change our behavior based on the answer to that question. What I have here is a fun flowchart for what to do if you've dropped food on the floor. Should you eat it or should you not eat it? Well, you might have some questions that you want to ask and change your behavior based on the answer to those questions, and that's what's going on in this flowchart here. But this flowchart is a bit of a complicated flowchart. If we're going to start to understand branching, it would be much better to start at the very beginning with a very simple flowchart to understand the idea. So let's do that. Over here on the right is my very simple flowchart. And I want to give you a first introduction to, in general, what the code looks like over here on the right, although we'll go through the syntax of branching very specifically later on in these videos. But in general, here's the way it proceeds and how the flow of control will change when we introduce branching statements. Imagine the computer going along, executing lines of code sequentially if you'd like. There's some code in your program prior to the point where you have a question. And we're thinking of these two green boxes as mimicking that. Next, we have a question that we need to know the answer to. In flowcharts, we often say yes or no to questions. However, in terms of computer programming, it's a little bit of a different mentality. Instead of asking a question, we'll just make a statement. And then that statement can just be true or false. So as opposed to asking a question, is the answer to this yes or no, we'll just pick one of those, make it a statement, and then say, is that statement true or false? So those tend to be the branches that we have in our coding. So we get to the point and the flow of control continues sequentially when we make a statement and we say, is that statement true? Now, when we're reading a flowchart, if that statement is true, then we follow that arrow in the diagram, and what's written over here in green is something that we want to do in that case, and we don't give any thought once that question is answered to what we would do if the answer were false. It's important to know what we would do if the answer were false globally, because remember, we often write computer programs to be run several times or to be run by somebody other than us. And so we need to know globally what to do in both cases. But then once we run the program once and we know the answer to that question, or we know if that statement is true or false, then we only want to do one thing. So globally we need to account for both possibilities. But once we run the program, we don't want to do both possibilities. We only want to do one possibility. So, assuming that the statement is true, we execute the code in green, and then what we want our program to do is not move sequentially any longer. Once this code is executed, we would like to totally skip what we would have done in the other situation, ignore all of that code, before moving on to the rest of the program. Again, because we don't know what will happen when the program runs, it may also very well be the case that the answer to the question or the original statement that we had been given is false, and we still want our computer to run and do something in those circumstances. We might just want to do something different. In that case, remember that this line of our code had executed, this line of our code had executed, but because the answer was false, we want to skip this bit of code and jump from this line of code right down to this line of code and execute this portion of the program. So our flow of control is making jumps over particular blocks of code. We need to understand some syntax of the programming language in order to tell our computer to make those kinds of jumps before resuming with the rest of the program in both cases. And that's what we'll be studying in our next video.